Good morning students, my name is Apul Naidu. I pursued my MSc in Organic Chemistry from Andhra University. I have 4 years of teaching experience in NEET and IIT JEE. In my experience, I observed that most of the students feels that organic chemistry is very difficult. Yes, organic chemistry is very difficult when you don't know the uses of reagent and most important named reactions from organic chemistry. Today I would like to explain one of the most important named reactions from organic chemistry. Those are Carbel-amine reaction and the second one is Wolff-Kishner reduction. Okay, now let us discuss the first one, Carbel-amine reaction, in detailed manner. Before going to discuss about the reaction and mechanism in Carbel-amine reaction, you have to remember two important points in Carbel-amine reaction. The first point is that it is also called as an isocyanate test. Carbel-amine reaction is also called as an isocyanate test. Now let us discuss the second point. Here this Carbel-amine reaction is only given by primary amines only. This Carbel-amine reaction is not given by secondary and tertiary amines. Here this point is very important. Why? Because Carbel-amine reactions is only given by primary amines. Now let us see the examples. Here RNH2. R bond NH2. Here R indicates the alkyl groups. That means simply aliphatic groups. Aliphatic, which means straight chain. For example, CH3 bond CH2 bond NH2. This type of bonds, this amine is called the primary amine. This type of amines gives the Carbel-amine reaction. The second one is aryl amines. That means aromatic amines. The most popular example is aniline. Now let us see the structure of aniline. Here NaH2. That means this structure is called the aniline. The amine is a primary amine. Here we observe that only primary amines gives the Carbel-amine test. Now let us discuss about the reaction. Here we observe that the primary amine, which having the lone pair of electrons, is reacted in the presence of CHCl3. Its name is chloroform. And in the presence of KOH. Here KOH, which means act as base, to form the R bond N plus triple bond C minus. It is called the isocyanide. The formation of isocyanide is produced and the byproducts are KCl and water. Here to balance this equation you have to put 3 moles of potassium hydroxide and 3 moles of KCl and 3 moles of water is. Now let us discuss the mechanism, that is the step 1, the formation of carbene. Here the chloroform is written as in this way. Here we observe that the electronegativity of chlorine is higher than carbon. That's why chlorine having the partial negative charge, carbon having the partial positive charge. Here the potassium hydroxide, which dissociates to form K plus and OH minus. K plus and OH minus. This OH minus acts as a base to abstract this proton, which is attached to carbon. That's why the bond between carbon and hydrogen shift towards the carbon to stabilize the carbon. So OH minus and H plus removed as a water molecule. Here the product formed is C minus 2 electron bond Cl bond Cl bond Cl. We know that in organic chemistry chlorine is a good living group. So one chlorine is removed as a Cl minus. So the carbon having the positive charge. This positive and negative charge neutralize to form C, 2 electrons, bond Cl and bond Cl. We observed previously K plus and the Cl minus combined to form as removed as KCl to form the C bond Cl and Cl. Its name is dichlorocarbene. Here the formed intermediate carbene is electrophile in nature. Now let us count the number of electrons. Here 2 electrons, 1 bond, which means 2 electrons. Therefore here 2 electrons and here 2 electrons. Total of 6 electrons. So in carbene there is only 6 electrons. It does not obey the octet. That's why carbene acts as an electrophile. Now let us discuss about the second step, how primary amine react with carbene. That means electrophile. Now let us see the step 2. That means primary amine react with carbene. We previously discussed that carbene is an electrophile, so it acts as an electron acceptor. Here amine, which are having the nitrogen having the one lone pair, it acts as a donor. So primary amine donates a lone pair to carbene to form a bond between nitrogen and carbene. Here R bond N plus. Why? Because nitrogen donates its lone pair to carbon. That's why positive charge present on nitrogen. Here two hydrogens and bond C minus bond Cl bond Cl. Due to the acceptance, the negative charge present on carbon. Let us react this compound with potassium hydroxide. Here we previously known that it's dissociated into K plus and OH minus. This OH minus which abstracts the hydrogen from nitrogen. That means this OH minus abstract this hydrogen. The bond between the nitrogen and hydrogen shift towards the nitrogen side. That means it is having the negative charge. We previously discussed that chlorine acts as a good leaving group. So one chlorine is removed as a Cl minus. Here carbon having the positive charge. This negative charge and positive charge form an another bond between nitrogen and carbon. R bond N plus double bond, nitrogen having the one hydrogen, bond C minus bond Cl. Now let us react this compound with another mole of potassium hydroxide. This will dissociated as K plus and OH minus. In this manner, this OH minus abstract the hydrogen which is attached to nitrogen. So this bond is shifted towards this nitrogen side, the nitrogen having the positive charge. We know that chlorine is a good leaving group, we discussed it previously. So it is removed as a Cl minus. So carbon having the positive charge. This negative charge and positive charge form another bond between nitrogen and carbon. Now let us see the product. R bond N plus triple bond C minus. Our required isocyanide product is formed. So its product name is isocyanide. This is the mechanism of carbolamine reaction. Here primary amines react with chloroform in the presence of potassium hydroxide to form the isocyanide. And now let us discuss the previous question on carbolamine reaction. A positive carbolamine test is given by. Here they are asking that among the four options which one gives the positive carbolamine reaction. To give the positive carbolamine test, we previously discussed that the amine must be present in, yes, exactly, primary nature. That means primary amine gives the positive carbolamine test. Now let us draw the structures of four options and verify the which one is primary amine among the four options. Now let us draw the structure of N, N dimethyl aniline. Here N, N dimethyl aniline structure is N bond methyl CH3 bond methyl group and presence of one lone pair. Here observe that this is the structure of N, N dimethyl aniline. Now let us discuss the second one, 2,4 dimethyl aniline. Okay, here at the second end aniline, that means NH2. Here they given that at the 2,4 position methyl groups are present. Here 1, 2, 3, 4. That means at the second position one methyl group is present and at the fourth position one methyl group is present. This is the structure of 2,4 dimethyl aniline. Now let us draw the structure of third one, N-methyl orthomethyl aniline. Here bond, here N-methyl, that means N bond hydrogen bond CH3 and orthomethyl. These are the ortho positions here, ortho, meta and para. At the ortho position one methyl group is present. So this is the structure of N-methyl orthomethyl aniline. Now let us see the structure of last one, that is para-methyl N-methyl aniline. Here at the para position, that means here in this position one methyl group is present and N-methyl, that means a hydrogen bond CH3 group is present. Nitrogen which are having the lone pairs. Here now let us verify the which amine is the primary amine. The first option N, N dimethyl aniline. Here we observe that here tertiary amine is present. So this option 1 does not give the positive carbolamine test. Now let us verify the second one, 2,4 dimethyl aniline. Here we observe that aniline which is primary in state. So our answer is 2 is our correct answer. Why? Because the 2,4 dimethyl aniline is present in primary amine. The primary amine gives you positive test of carbyl-amine reactions. Now let us verify the remaining options. Here this amine is present in secondary amine. Does not give the positive carbyl-amine test, and fourth one is this amine is also present in secondary amine. So this option is also does not satisfy the carbyl-amine reaction. In this way they ask the questions on carbyl-amine reaction. I hope this concept is clear to you. Now let us remember what we have discussed in carbyl-amine reaction. These 4 points which are very important with respect to exam point of view. Here the first point is that the carbyl-amine reaction is also called as an isocyanate test. The second point is that only primary amines gives the carbyl-amine reaction. This point is very important. And next point is that the intermediate, in examination they ask that what is the intermediate formed in carbyl-amine reaction. Here we discussed that the carbon intermediate formed in carbyl-amine reaction, which is electrophilic in nature. The last point is that how many moles of potassium hydroxide used in carbyl-amine reaction. So 3 moles of potassium hydroxide is used in carbyl-amine reaction. These are the 4 points which were very important with respect to exam point of view. I hope this concept is clear to you.